Hello, and welcome to the Aggie Robotics Sumobots Electronics Setup and Quick Start video. In the next about 8 minutes, we're going to look at the various electronics components, get them configured and set up, and get everything up and running so that you should be good to go. The first thing you're going to want to do is you're going to want to visit our GitHub repo, Aggie Robotics Pi Setup, and over here in the Releases tab, download the latest release. The release is about 1 gig zipped. It unzips up to about 3 gigs. And when you image it onto the SD card, you're going to need an SD card that's at least 4 gigs. The one I have here and the one that comes in most of the kits is either 8 or 16. So you'll be plenty fine on that. What you're going to want to do is take your adapter, if it's an SD adapter or if it's a USB adapter, put the micro SD card in there and plug that into your computer. Then you're going to want to go to the Raspberry Pi Imager. The Pi Imager is a software utility that will write that image onto the SD card. So here I've already selected the unzipped version of that OS image that you just downloaded. To do this, you go into this thing and select custom and you select that file. Then you choose the SD card and you click write. This process takes about 5 to 6 minutes. So while that's happening, we'll take a moment to look at some of the other things that come in the electronics kit. Most notably, you have the Raspberry Pi Zero with headers. This is the logic control board for the Wi-Fi and the server communication. Then you have the Adafruit 4280 board. This is a dual H or it's a two-stepper or quad DC motor driver board. It communicates via I2C back to the Pi. And it has these great push to connect fittings on the bottom of it. So literally all you do is line up the pins, put it on there, give it a nice push, and then you've put these pieces together. Obviously they should line up. Uh, if they don't, you have it on the wrong way and you should fix that before you try to plug it into anything. Next we're going to want to connect our motors. So what you have here is you have two sets of these 5x1 headers. The outside of each of the sets of 5 is a pair of DC motor controllers, and the center being the common ground. The common ground is used if you're driving certain types of stepper motors, so we're just going to ignore that. We don't need it. We're going to take our motors and plug them in to these spots. There's motor 1. Here comes motor 2. For the current version of the Raspberry Pi software, or of our software, the you need to use motor 1 and motor 2. However, that's relatively simple to configure on your own. The direction you plug these in doesn't matter. However, I like having them where the pairs are the same way, so both blacks and both reds. To keep them from falling out like that, you're going to want to take a screwdriver and tighten it down. And then get this one back. Put it in there. Finally, you're going to want to connect power to this motor board. So the power goes in here. This one is directional, but it has protection, so you probably won't break it if you screw up. On this, you'll see a plus and a minus. DC electronics, so positive is red, black is ground. You either can take something of this variety, which is a USB-A to just the power part of it connector. That means the two data cables that are in the USB are not connected. You can also take something like this, which is this is an old iPhone charger, and when you cut it and cut the outside casing, you'll find all 4 of those wires in there, and then you can strip it down and solder a header onto it if you want, or just use the raw wires. That can work too. In either case, you're going to want to take this, plug it into your motor board, give it a tighten there, and then you're good. You're ready to install it. So on this is the default chassis. The motor board has to go in that way because of how the headers are spaced. You can put these motors in. They also have to go in one way because of the bump on the side of the motor. Put that there. The other nice feature is that you can actually guide the wires down here through the center. There's a small gap, and that helps keep the wires tucked away and, out of the way as things happen. We'll put that other motor in. Take our power cable. It also gets tucked under, like so. The last thing that we're going to need to do is we're going to need to take this power cable. So this is the charging cable for the USB battery pack that comes with it. But this is USB-A to micro, and this micro connector is the same type that's used on the Raspberry Pi. So you'll see that there's two of them here. This one that's more towards the outside of the board is the one that power needs to go into. So we'll plug that in there. We'll run the cables under there, and then just put our battery in to be ready. Now we're done here imaging the Raspberry Pi SD card, so we'll remove it from the adapter. Take this, so we're just going to slip it into the slot on the Raspberry Pi for it. Put that down. And now we're ready to connect things to power. The first time that it boots up, it'll take about 2 to 3 minutes. However, after that, it should be much faster. If you look down into the sandwich, this LED here, which is on the Raspberry Pi, will blink a couple times as it initializes, and then it should be solid. This LED here on the motor board is just on whenever there's power through the motor board. While we wait for that to boot, we'll take a moment to look at some of the other things in the GitHub repo. So here in the GitHub repo, we have, most importantly, this quick start file. This contains a lot of the instructions that I've just walked you through, but also the default values for things that are in the image. For example, if you need to log into the Raspberry Pi, there's the username password information. That is the default that comes with the Raspberry Pi, so security not is exactly as high as it should be. These are the two main files you have to worry about. Index.html is the HTML file that's served to the web client when they connect. And then we have server.py, which is the Python server that runs in the background to do things. They both sit in this HTML directory. This is technically a protected directory, but in the image that's provided, we've removed the protections, so that's great. Makes it very easy to work with. Here we have the Wi-Fi username and password, or Wi-Fi network name and password. What this will do is when you connect to, or once the Pi boots, you'll find a Wi-Fi network available on your network device. You'll connect to it with that information. Then you take your web browser and you go to this host address, 192.168.4.1. All inbound connections that are IPs should resolve to this address, but just in case it doesn't, it's good to put that one in directly. You click go, and you'll get connected. If the background turns green, that means that it's successfully established communication with the Pi server, and then you can just make the motors move. Make this more visible, we'll put on a wheel. We'll try to put on a wheel. Matching shapes is very hard. And it's that simple. So in just under 10 minutes, that's how you go from a pile of parts to a ready-made robot. Now all that's left is for you to do your design. We look forward to seeing what you come up with, and reach out in Discord with any questions.